sharing the screen. And you guys don't need to see my email. You need to see that today's April 14th. We're going to look more at compound interest. We only did problems where we were solving for the future value. We're going to find that there are questions where you know the future value and you need to figure out what the principal would need to be to get that future value. Then we're going to look at yield, which is a way of comparing different compound interest possibilities, because I think we noticed in class that the more frequently it's compounded, the higher the interest. And so at some point in time, which is more important, a slightly higher interest rate with fewer compounds or more compounds with a slightly lower interest rate. So we'll look at how to make that type of comparison. And then if there's time, we'll look also at the idea of an annuity, because we're going to find that sometimes, depending on what you want your future value to be, it's tough to come up with that much of a principal. And so instead of doing it all at once, you do it in small installments, and that's when it becomes an annuity. Before we get started with that, homework 8.1 was just on percents. That was due on Monday. Homework 8.3 is the homework on simple interest, which is what we had looked at last week. And then that homework 8.4, which initially was scheduled to be due tomorrow, and I said, wait, that's a mistake. We'll push that back to Monday because we're still working on that stuff today. Does anybody have any questions on any of the homework problems, either just the percents, the simple interest, or the compound interest? Okay, total silence means either you folks haven't started it yet, or you're really comfortable with it.
That was the one that was due on Monday, right?
The 8.1 is the one that was due on Monday. That was just
that has 20 questions.
I have to tell you, I don't remember. 8.1 had.
I think it has 20.
Well, I struggle with the last one, the 20.
Okay, let's look at number 20 then. Question number 20 says that a man originally paid $3,400 in property taxes. What will be his new tax payment if he saves 10% this year? Okay, well, let's see. If he saves 10%, that would mean that we need to find 10%, which as a decimal is 0.10. And the only thing that I can see that we can take the 10% out, what he'd be saving on is the property taxes. So 10% of his property taxes would be 0.10 of means multiply. The taxes is 3,400. And so that gives me $340. And so that's how much he's going to save. So if he's saving that much, what will his new payment be? Well, it was 3,400. And if he's saving 340, his new payment would be 3,060. Does that make sense?
You made it look so easy.
But we've got to the phraseology of the question tells me that we've got to find 10% of something. So what we're finding 10% of, the only number that we've got there is the property taxes. And now if he's saving money, well, we've got that 10%. We've got two options. We can add it or we can subtract it. If he's saving money, that tells us, if you're saving money, you're spending less. So it's going to go down. So we'll subtract. Better?
Yes.
And honestly, please, if you're struggling with a homework question, don't use that Ask My Instructor button to send me a question. Because I could very easily go through that with you via email. Does anybody want to look at any of the other ones from this assignment?
Did you go over number 20?
Oh, we just did. Oh, was it? No, that was number 1. I thought that was number 20. I thought that was
No.
number 20. I apologize. I thought I clicked on number 20.
Oh,
Let's-
I'm glad you mentioned it because that was the one I had a problem with, number 20.
Yeah, and I thought that that was
I'm
number
like, oh my
20.
gosh, it was that.
Oh, the one. Yeah, this question is probably the most involved one. It says, in January, each of 70 people purchased a $400 washing machine. In February, 10% fewer customers purchased the same washing machine, but the price had increased by 20%. What was the change in sales from January to February? Well, let's first look at January. In January, 70 people paid $400. So the sales was 7 times 4 is 28, $28,000. Everybody all right with that part?
Yes.
Yeah.
February, they had 10% fewer customers. So let's see, 10%, 0.10 times the number of customers, 70, would be 7 fewer. So that means they had 63 customers. Everybody all right with that one?
Yeah.
The price is 20% more. So if I take 20% of the price, that gives me $80. And so the new price, if it's $80 more, the new price is $480. That part all right. And so for February, I'm selling 63 washing machines at $480. So 63 times 480 gives me that it is $30,240. Oh dear. Did the sales increase or decrease?
Increase.
Increase. So that tells me the change from January to February was an increase. And how much of an increase? Well, when I subtract, I get $2,240. Why is my keyboard not coming up? Better?
Yeah.
It's kind of a fun question because you're selling less, but the price went up. Do the price go up enough to make compensate for selling less or not? And obviously it did, because even though we sold fewer, we made more money. So. And again, I think you probably noticed that some of the questions in the homework are kind of make you think questions that are a little bit above and beyond what we've done in class. And that's intentional because I've seen all sorts of studies that say if you have to work a little bit harder on your own, you get a little bit prouder when you get it, and you put more skin in the game, which means you're more likely to remember it. So honestly, it's intentional. So I guess you can get mad at me, but it's supposed to be good for you. So. Any other questions from this homework? And I apologize that I did number 1 instead of number 20, because honestly, I thought I clicked, well, I know I clicked on that number 20. I don't know why it didn't come up.
And I knew it looked too easy. I know the question was.
Yeah,
more to
I
it
was
than that.
surprised with that one. But you see how this one really isn't that different, except you've got to do that twice. You've got to find the 10% decrease. You've got to find the 20% increase, and then use that to find the total sales.
The 400, is it, do we have to do the parentheses when we do it on a computer? I mean, on the
No.
calculator?
And again, when I took that 20% of 400, when I write it as
0.20 times 400, right?
0.20 times 400. When I write it by hand to show multiplication, I put one number in a parentheses because I've been doing algebra long enough that if I put an X in between, it's like, oh wait, does that mean multiply? Or does that mean a variable? And so I'll put one, when I'm multiplying just numbers, I'll put the numbers in parentheses to make it clear that I'm multiplying. You don't have to type those parentheses in.
Okay.
Okay. Although over here, I did use the X for multiplication. Go show. Consistently inconsistent. Sorry, guys. Does anybody want to look at any other from this homework? Or from that simple interest homework that's due on, when is that due? The simple interest homework 8.3, which is due on Friday.
I wouldn't mind personally, because I'm struggling
All
a
right.
little bit.
Which questions? Should we start at the end?
Sure. Usually it gets harder towards the end anyway.
Let's see if I can actually pick the right problem. I think the problem,
I only did like 4 questions.
okay,
Then I stopped because I was struggling a bit.
all right. So did you want to look at question number 5 or did you want to look at question number 15?
Yeah, let's do that.
5 or 15?
Let's go for the 15. I haven't looked at that one yet.
Determine whether the statement makes sense or does not make sense and explain your reasoning.
Oh, we don't see your screen.
You don't see the screen.
No, the sharing screen. No, I do now. Okay, must be
Okay.
on my end.
All right, let me do it again. Okay, it says, I plan to save $5,000 in 4 years and computed the present value to be $3,914.742. So I'll round it to $3,914.74. Okay, so looking at the choices, the statement does not make sense. The principal should not be rounded. Well, you can't do a fraction of a penny. And so I'm going to skip that one. The statement does not make sense. The principal should always be rounded up. And that I agree with. The principal should always be rounded up. But the last one here says the statement does not make sense because the present value is not correct. And I don't know about that one because we didn't do the work. So let's do the work. We know that with simple interest, the future value is equal to the principal times 1 plus the rate times the time. Our rate here is, oh, you know what? They don't give us a rate. And so I'm going to guess that C would be the correct answer because they didn't round up. Shall we see? And that's really all they were looking for. Remember, we had said that when you're looking for the present value and you know what you want in the future, you're always going to round up. We can't do the computation because they did not give us the interest rate. Should we try the one before it also?
Sure.
A bank offers a CD that pays a simple interest rate of 9.0%. How much must you put in this CD now in order to have $2,500 for a home entertainment center in 3 years? All right, question of the day. This money, whoops. This money, is that what we have now, or is that what we want in the future?
In the future.
That's the future. So since that's the future, we'll use our future value formula. But we know the future. We know that $2,500. We know the rate is 9%. And be very careful. You will not get it correct if you don't change that into a decimal, 0.09. And we're told that we need it in 3 years. So that'll be my time. And we want to know how much we have to set aside now. So we're looking for that principal. To that point, is everybody comfortable?
Yeah.
So this gives me $2,500 is equal to my principal times 1 plus 0.09 times 3. I can't just type it right in my calculator because I've got that variable on that side. But what's in the parentheses, I can type in my calculator. And that'll give me 2,500 is equal to P times, that would be 1.27. And then because this is multiplication, to solve for P, we'll have to divide. And so this one, I'm not going to try to do in my head. 2,500 divided by 1.27. My calculator gives me that I'll need 1,968.503,937. And notice in the words, they're not leaving it up to you. They're telling you to round up to the nearest cent. So that'll be 1968 and 51 cents. Because if it says round up, we're not going to use our regular rounding rules. We're always going to, as long as that isn't a 0, we're always going to add on. Okay. Any better?
Some.
All right. And again, it's just pick your formula. Identify what you know. Put those into your formula. Use your calculator. When you've got a variable on that side. And I think that's really only going to happen to us with the simple interest. Realize that to solve for that variable, if it's multiplication in between, we have to divide both sides. So, is it all right if I clear this?
Yes.
Then let me turn my cursor back into a mouse. Did you want to look at that question number 5, or shall we carry on to our,
Can we do number 10?
number 10? Sure. Determine the present value P that must be invested to have the future value A at the interest rate R after time T. So future value, that's A equals P times 1 plus RT. And so we know that A is 3,000. R is 17%. Remember to change that into a decimal, 0.17. T is 3 years. Since it's in years, we'll leave it. When I substitute, A is 3,000 equals, I'm sorry, the pen, when I use this Zoom pen, is does not work real well. Can you guys still read that? P is what we're looking for. R is 0.17 times T is 3. Do what's in the parentheses when you take 1 plus 0.17 times 3. And again, you don't need parentheses for that. You're going to just type in 1 plus 0.17 times 3. What do you get? Anybody else doing it? I get 1.51. Now, because we're looking for P, this is times P. We get P alone. The opposite of multiplication is division. So I'll divide both sides by that 1.51. So when I take my calculator, 3,000 divided by 1.51, I get P is 1986.754. And again, it tells me to round up. So to the nearest cent, it would be 1986.76. Any better?
Yeah.
Great.
We carry that 1.51, that number to the right.
Whatever, with an equation,
Mhm.
whatever you do to one side, you have to do to the other. And so over here in this equation, I'm going to erase this part for a minute. What we've got is 3,000 is equal to our variable times 1.51. When we're solving an equation, we're always trying to get that variable alone. So to undo this multiplication, we have to, the opposite of multiplication is divide. So I have to divide by 1.51. But because it's an equation, it's a balance. Whatever I do to one side, I must do to the other.
Okay.
On this side, when I divide the number by itself, it gives me 1p. A simpler looking example along that line of reasoning is if I said 2x equals 4, 2 times the number is 4. To find out what the number is, to undo that multiplication by 2, you have to divide by 2. What you do to one side, you do to the other, and you get x equals 2. It's that same line of reasoning that you would use in an equation like that. It's just that our numbers are kind of crazy decimals instead of pretty numbers like 2 and 4. All right?
Okay.
Then let's clear those. Let's go over here and let's, before we look at compound interest solving for the future value, let's do a real quick refresher on where we had left off. We had said that for compound interest, A equals P times 1 plus R over N to the NT, where A is the future value, R is the rate as a decimal, T is the time in years, and N is the number of compounds per year. And so let's say that we're going to invest. How much money do you guys want to invest?
$1,000.
$1,000. And let's say, let's do slightly more realistic interest rates, 1.5% interest. Let's have it compounded monthly. For how long do you guys want to leave this money in the bank?
10 years.
10 years? So our formula again is A equals P times 1 plus R over N to the NT. I'm going to be quiet for 2 minutes and ask you guys to do this. Guys, current interest rates suck.
I'm gonna ask a silly question. Where is the 120 coming from?
NT
Mhm.
means N12 times T 10. When they're written next to each other, we multiply. It's not a silly question at all.
Thanks.
I find it easier if we multiply those out before we put it in the exponent. Because otherwise you need to throw some extra parentheses in that equation, and I don't think anybody wants to use the parentheses key more than they have to.
And the 12 is because it's monthly, right?
Right.
Okay.
If anybody needs a refresher, we had said annually would tell me once a year, N is 1. Semi-annually would be twice a year, N is 2. Quarterly would be 4 times a year, N is 4. Monthly is 12 times a year. Weekly is 52 times a year. And daily, we're using that banker's year, so it would be 360 times a year. And I think we've got that written down already, just in case anybody needs a refresher. Did everybody get that $1,167, $61, pardon me, and 73 cents? $1,161.73.
Yeah.
Yeah, you would hope
Yeah.
after 10 years, you'd get more interest than that. But right now, interest rates are ridiculously low. So hopefully, at least in terms of borrowing, low interest rates are good. But in terms of savings, low interest rates are bad. Hopefully that will correct itself soon. So we've got this formula for, again, compound interest. Where if we're looking to find the future value, A is equal to P times this ugliness, 1 plus R over N to the NT. So we can look at this as just A is equal to P times all of that stuff. Well, sometimes we know the future value and we want to find the principal. And to find the principal, if we know what we want the future, well, if A is equal to P times that stuff, excuse me, algebraically, it will make sense to say that P is equal to A divided by all of that nonsense. And again, the formula with a fraction in it, the big fraction in it, looks cumbersome, can almost look overwhelming. But really, we're going to do the exact same thing. We're going to choose the right formula, identify our variables, substitute in, and type it very carefully into our calculators. So let's look at an example. Let's say we want, oh, I'm going to daydream, $500,000, $500,000 in 30 years. So think about when you guys might want to retire in 30 years. We're going to be able to invest at 4% interest, compound it monthly. How much should I invest? So do you guys want to have $500,000 in 30 years when you're older? And yeah. How much money should we set aside now if we can find something that pays 4% interest? Is it clear that that $500,000 is not what we have right now, but our future value? And we're looking for our present value. Our rate is 4%. We have to remember to write that as a decimal, 0.04. Our time is 30 years. And if we're compounding monthly, N is 12. And again, I like to pre-multiply NT would be N is 12, T is 30. So that would be a total of 360 compounds. To that point, identifying my variables. Is everybody comfortable?
Yeah.
Yeah.
Since we're looking for P, we're using the formula where P is alone. So that's P equals A over 1 plus R over N to the NT. So A is that, plugging in $500,000 over parentheses. And if the parentheses are in the formula, those are important to type in. 1 plus R is 0.04 over N is 12. And NT, again, it's easiest if we pre-multiply. That's an exponent of 360. So to type this, okay, I'm racing.
You said on this one
Down.
is required
this-
parentheses, right? On this one?
We need the parentheses, yes. Is everybody all right with just the substitution part, replacing the variables with the correct quantities?
Yeah.
Typing then, I would type in that 500,000 times, oh no, take that back, it's not times, I apologize. Because it's a fraction, we need divided by. Then we need our parentheses. 1 plus 0.04. For that fraction, I'd also use divided by 12. We're going to close the parentheses. And then we're going to use our exponent key to raise it to the 360th power and hit equal. So again, we're typing 500,000 divided by, and if the parentheses are in the formula, it's important that we use them. Parentheses 1 plus 0.04 divided by 12. I'm going to stop there after I close my parentheses. And looking at my display where I typed that 0.04 divided by 12, it actually physically looks like the 0.04 over 12. And for the exponent, I'm going to carry it up 360. And so it tells me that I need 150,897.9326. Let's round again when we're looking for the present value up. And let's do this one to the nearest dollar. And so that would give me $150,898. So if you can find 4% interest and you want $500,000 in 30 years, does everybody have a spare $150,898 now?
Nope.
No.
No. But if you did, you could invest it that way. Let's look at another example. This time, let's say we're new parents and we're going to assume that college will be $120,000. And a kid will be going to college when they're about 18 in 18 years. And right now, interest rates are kind of low. So let's say 2% interest. And let's say it'll be compounded quarterly. So how much should we put in the bank now? And again, the present value is equal to the future value over parentheses, 1 plus R over N, close parentheses, to the NT. And I'm going to be quiet and give you guys a couple minutes to get this one.
You want us to round?
Yeah, let's round up to the nearest dollar.
Okay.
Is anybody else getting $83,797?
Yeah.
Okay. So, doesn't look real good. I don't have $83,797 now for a kid to go to college in 18 years. So we'll look at other possibilities a little bit later. But how much interest did we earn? Again, the interest is always going to be the difference between the future value and the present value. And so at the end of that time, we've got that $120,000. And all we put in was $83,797. And so how much did the bank give us? The bank gave us $36,203.
I'm sorry, I have to leave right now.
Okay,
Get to my next class. Have a nice day.
all right. I've got that it's 1:45. We still have 5 minutes, don't we, guys?
Yeah, I have to leave early.
Okay. All right.
Sorry about that. Bye.
Bye. So then, next thing we're going to look at is the idea of yield. When I look at the idea of yield, we're looking at the effective yield. And we use it to compare rates with different compound periods. The formula is y equals 1 plus r over n to the n minus 1. And that kind of levels the playing field so that we can compare different investments. So an example might be, which is better? 8% compounded monthly, or 8.2% compounded annually. And so when I'm comparing, I'm going to use the yield formula twice. And so let's just take a guess before we do the problem. 8% is a lot lower than 8.2%. We've got a lower interest rate. But compounding monthly is a lot better than compounding annually. Which will be better? I'm going to use that formula. For the first one, 8% monthly. My rate is 8% or 0.08. Monthly means N is 12. And so my yield would be 1 plus 0.08 divided by 12 raised to the 12th power minus 1. And I'm going to ask you folks to type that in. Again, the parentheses are there, part of the formula, so you need to put them in. If your calculator makes a superscript when you raise it to the 12th power, you need to arrow out of the exponent before you subtract the 1. And I get this crazy long decimal. Is anybody else getting 0.08299995 and it keeps on going? Our next option is 8.2% annually. So here the rate, 8.2% is 0.082. And annually means once a year, so N is 1. So when I substitute, that gives me Y equals 1 plus 0.082 divided by 1 to the first power minus 1. And when we type that in, is anybody else getting just 0.082?
Yeah.
So now what we have to do is compare them. And when I do that comparison, the first 3 digits are the same. For this one that ends, the next digit would be a 0. So I'm going to compare that digit that's different. And does everybody realize 9 is higher than 0? So this is a higher yield. So it would be the better investment. And again, you're going to find a couple of questions in that homework for section 8.4, which again won't be due until Monday, that asks you to compare the yield on different compoundings. All right.
Okay.
Now I'm looking and it's about that time. So I know that somebody came in late. If you came in late, please stick around and tell me. Otherwise, we will see you on Friday. Bye-bye. Have a good one.
Thank you.
Bye. See you on Friday.
Bye.
Bye-bye. Jaden, are you there?